Hello friends, here is a number that should get your attention right now. According to the Pragmatic Engineer's June 2026 analysis of job market data, Google currently has 62% more software engineering roles advertised than it did a year ago. The market is open. But here is the catch. The rules of what gets you hired have shifted in a fundamental way. Raw memorization of algorithms is no longer the bar. In 2026, the top employers, including Meta and Google, have redesigned their interviews to test something much harder: your ability to decompose a problem, debug an unfamiliar codebase, and defend every decision you make in real time. In this video, we break down exactly what problem-solving means to employers today, how to train it deliberately, and how to prove it. Let's get into it. Before you can improve your problem-solving skills, you need to know exactly what employers are testing. It is not just, can you write code? According to Carrot's 2026 Engineering Interview Trends study of 400 engineering leaders, what separates strong engineers from weak ones breaks into 4 layers. First, requirement decomposition. Given a vague prompt, can you slice it into clear, concrete subproblems? Second, algorithm selection. Do you understand enough data structures and trade-offs to choose the right tool? Third, debugging and verification. Can you read unfamiliar code, find a root cause, and confirm your fix actually works? Fourth, communicating trade-offs. Can you explain why your solution is shaped the way it is? These 4 layers are the real bar. Code that runs is just the baseline. What comes next is mapping them to the problem types you actually need to practice. Alright, so there are 3 core problem categories you need to build reps in. The first is algorithmic problems. This is your classic LEET code territory. Think arrays, trees, graphs, dynamic programming. The goal is recognizing patterns and understanding the time and space complexity of your solution. The second category is system design. Here the question is not, does this code work? But how do you build something that scales? You need to reason about trade-offs between consistency and availability, between latency and throughput. The third, and increasingly the most important, is real-world debugging. You are handed an unfamiliar multi-file codebase and asked to find a bug, extend a feature, or optimize a bottleneck. This is what real engineering actually looks like every day. Notice how each category maps directly to one of the 4 layers we just defined. That is not a coincidence. Now let's talk about how to actually build all 3. Here is the training loop that actually works. Step 1 is daily structured practice. Pick one problem on LeetCode or AlgoMonster, set a timer, attempt it, then study the optimal solution even if you solved it. The pattern recognition builds over weeks, not days. Step 2 is think aloud sessions. Force yourself to narrate every decision as you type. I am choosing a hash map here because lookup needs to be constant time. Do this alone first, then with a practice partner. Step 3 is open source contribution. Clone a real project on GitHub, read code you did not write, and fix an actual bug. This is the closest simulation of what employers now test. Step 4 is building projects with real architecture decisions. Not toy apps, something where you have to choose between a relational database and a document store, and defend that choice. These 4 habits compound. Each one trains a different layer of the 4 we defined. You can see exactly what employers now measure by looking at Meta's AI-enabled coding interview, piloted in October 2025, and rolling out across software engineering roles in 2026. The format is a 60-minute CoderPad session built around a real multi-file codebase. Phase 1 is decomposition, where you read unfamiliar code, locate a bug, and break the problem down. Most interviewers recommend skipping the AI assistant here, because this phase tests pure analytical thinking. Phase 2 is AI-assisted implementation. Meta gives you a choice of models, including GPT-5, Claude Sonnet 4.5, Gemini 2.5 Pro, and Llama 4 Maverick. You can use any of them, but you must write and understand every line yourself. Phase 3 is the defense. The interviewer asks you to explain every decision, including code the AI helped generate. Candidates who blindly pasted AI output without understanding it are caught immediately. The 4 skill layers we defined are exactly what this interview measures. Building the skills is only half the job. You also need to make them visible. There are 3 proof channels. First, a GitHub portfolio, not a collection of tutorial clones. Employers look for projects where the README explains your architecture choices, the commit history shows real iteration, and the code solves a non-trivial problem. Second, STAR method behavioral stories. STAR stands for situation, task, action, result. Prepare 2 or 3 stories where each one is anchored to a real bug you hunted down, or a design decision you owned and defended. Third, thinking out loud during technical interviews. Silence reads as confusion. Every time you choose an approach, say why. Every time you spot a trade-off, name it. Carrot's 2026 data confirms that live interviews are now the most valuable signal for employers, precisely because they reveal how you actually think, not just what you can produce. Now let's bring it all together. Let's wrap this up. The core insight from everything in this video is that problem solving in 2026 is a 4-layer skill: decompose, select, debug, and communicate. McKinsey's research shows AI tools can boost routine coding productivity by 20 to 45%, but system design and novel debugging still require deep human judgment. That is your competitive edge. Train it with the deliberate loop: daily algorithmic practice, think aloud sessions, open source debugging, and projects with real architecture decisions. Prove it through your GitHub portfolio, star method stories, and thinking out loud in interviews. The weekly schedule on screen gives you a concrete starting point. Monday and Wednesday for algorithms, Tuesday and Thursday for system design, Friday for real codebase debugging, Saturday for portfolio commits, Sunday for behavioral rehearsal. The hiring window is open right now. The engineers who land great roles in 2026 will be the ones who treat problem solving as a trainable skill, not a personality trait. Start this week. See you in the next video.